Hello, wonderful person. This is Aaron speaking, and in this video, we will be talking about properties of quadrilaterals. So let me write that down for you. Quadrilaterals. And what a quadrilateral is? A quadrilateral is any four-dimensional, not four-dimensional, four-sided two-dimensional figure. Similar to how a triangle is any three-sided two-dimensional figure. And by two-dimensional, I just mean flat. Now, the for the sake of the GKE, you do need to know about the two different classifications of quadrilaterals. They can either fall under trapezoids, and if it's not a trapezoid, the other classification is parallelogram. Parallelogram. And what are they? A trapezoid is a quadrilateral that only has one pair of parallel lines. So let me draw an example for that. These are parallel lines because they go in the same direction, but they never intersect. However, these two lines are not parallel because if I were to extend them, they would eventually intersect with each other. So trapezoids is any quadrilateral that only has one pair of parallel lines. The difference between that and a parallelogram is that parallelograms have two pairs of parallel lines. And that's what makes a quadrilateral parallelogram. And here's an example. This four-sided figure has a pair of parallel lines here and a pair of parallel lines here. Oh my gosh, that's such a tongue twister. Pair of parallel. Try saying that 5 times. Pair parallel. Anywho, split into two different classifications. We have rhombus right here, or they could be a rectangle, which I'm sure most of you are familiar with. Now, a rhombus is a parallelogram that where all sides are the exact same length. So looking at that figure, it looks like a slanted square, but notice how opposite sides are parallel and all sides are the same length. Assuming it's proportional. I'm not an artist, please forgive me. Now, a rectangle is a parallelogram where all four angles are right angles. So none of the angles are left because they're all right. So please excuse my corny jokes. Anywho, so if you notice, it's just like the parallelogram here. The only difference is that they're right angles, which will usually be indicated either in word form, so they'll tell you it's a rectangle, or they will have the boxes at the corner. And keep in mind, I said in an earlier video, the boxes are indication that you have a right angle. Now, a parallelogram that's both a rhombus and a rectangle. Could you think of one where all sides are the same length and all angles are 90 degrees? And if you didn't, you're most likely familiar with this shape because it's the most popular quadrilateral. And it's a square. I get called that all the time. Anywho, a square is basically it's a rhombus and a rectangle because all sides are the same length, which is the properties of rhombus, and all angles are 90 degrees, which is a property of a rectangle. So in terms of classifying a quadrilateral, using this diagram, you need to know all the different classifications a shape could say. So let's say for the exam, they give you a figure that looks like this. And they ask, what are which of the following is a way you could classify this shape? Or they might say which of the following isn't. A rhombus, for an example, looking at this diagram, could be it could be classified as everything above it. So a rhombus is also going to be following this line. It's also a parallelogram. And all parallelograms are also quadrilaterals. So if they gave you a shape like this, rhombus, know that it could be everything that's above it. However, not all rhombuses run by, I don't know what multiple rhombuses are, but not all of them are squares. They could be a square, but not all are squares. So just know how to classify and the different ways to classify a single quadrilateral. based off of this diagram here. And these are the only different classifications you'll need to know for quadrilaterals for the exams. Now, one property of quadrilaterals that I do want to discuss in this video, which is the last important property that you're going to need to know, is that the sum of all the interior angles of a quadrilateral will always be equal to 360 degrees. As you recall, for triangles, it was 180 degrees. So how would that apply in a problem? Let's say we have a quadrilateral and they gave us three of the sides. So let's say here, this was 150 degrees. Let's make this one 40 degrees. And let's make this 90 degrees. We could use all this information to solve for the fourth angle of this quadrilateral. And this is not drawn to scale, by the way. So the way we do that is we add all of the interior angles. Let's call this angle A. So 90 plus 150 plus 40 plus A has to equal 360. And the reason why is because they're in a quadrilateral. So first let's add all of these angles. 150 plus 40 is 190. 190 plus 90 is 280. So 280 plus A is equal to 360. So we can subtract 280 on both sides. So that gives us A is equal to 80 degrees. So you could use this property to solve for inside any parallelogram. Now, or quadrilateral in general. Properties when it comes to parallelograms specifically, notice how when it comes to parallelograms, you also need to know all opposite sides on parallelograms will always be the same length. That doesn't apply to trapezoids, but it does apply to all parallelograms, which means anything underneath it. So rhombi, opposite side are the same length. Rectangles, opposite side are the same length. That applies for all parallelograms. And not only are opposite sides the same length, so are opposite angles. So those are all the properties you're going to need to know for quadrilaterals for any question related to one on the GKE. Thanks for listening. Hope you learned and stay awesome. Have a nice day.